Thank you so much for having me, and thanks for including a talk on soil. I've got about 20 minutes, I think, to talk, and then we'll have hopefully some time for questions. So, my name is Matthew Evans. I run a farm in southern Tasmania. I'm a chef by trade, so I've been interested in the food system. Well, I guess like most of us, we're pretty interested in food. I've been interested in the food system since I left school. Started as an apprenticeship in Australia. Did a 4-year apprenticeship. I became a fully qualified chef. Then I became a food writer. And now I'm a farmer. So I live in southern Tasmania. So if you think of Australia, think of the island off the bottom of Australia, and you go to the bottom of the island at the bottom of Australia, that's where I live. So you go any further south than me, and you end up in the Southern Ocean. So we have a 70-acre farm there, and it's a mixed farm, so we grow a variety of crops. As Lee said, I literally wrote the book on soil, a book on soil. I wrote it. I just want to give a little bit of background. I'm a chef by trade, and I became a food writer. So I've written 15 books over the years, and most of those were recipe books. And I don't know what it's like in Singapore, but I think it's probably like everywhere else in the world. For some reason, it does not matter how many recipe books are already out there; they will still publish more. Right? I'm Australia's least read food writer. Right? And even I've got 13 books on food, recipe books, 12 recipe books. So it seemed quite odd. So when I could publish recipe books because I'm a chef. I have a restaurant, and some kind of I'm on I had a show on a national broadcaster in Australia, so I had a bit of a profile. And so it seemed like you could just publish recipe books forever. But as a farmer, as I was growing food, I started to get interested in other things. And obviously, when you're growing food, you start to get interested in what it grows in. And where I live, we grow it in soil. And so I got this idea, because I didn't really understand soil. People used to talk about healthy soil and, is soil, the nutrients in soil, or how healthy is soil. And I was a food writer, and I go to visit farmers, and they'd say, my asparagus tastes really good because of healthy soil, or because, I'm growing really good lettuce because of healthy soil, right? And I, as a food writer and a chef, used to think, what? I had no idea what they were talking about. You kept banging on about it. Now I know, by definition, what they mean is that healthy soil is alive. It's a living, breathing superorganism. So I went to my one of the first things I learned about living soil as a grower, as a farmer, trying to work out why some of my crops would grow well I'd have the same sort of garden bed, 15 metres long. I'd plant the same crops, say broad beans, in that row, and I would find that the same seeds, the same sunlight, the same essentially soil, it looked like, the same water, they're all limiting factors for growth. And my broad beans would grow in a different pattern all the way down the garden bed. And I'm wondering, why do they grow in a different pattern? And so I had questions about soil. And one of the first things I learned was this idea that soil is alive. And when I say alive, I didn't really think about it much. I thought, some worms, and I've seen some other things living in soil. But it turns out that soil is super alive, and good soil is amazingly alive. See, the amount of soil that would fit into the end of my thumb, 1 teaspoon of soil, has more living things in it than there are humans on the planet. 10 billion living things in a teaspoon of healthy soil. So they're mostly bacteria, some fungi, some microbes, some things called archaea, single-celled organisms, and there are bigger things, nematodes, like little worm-like creatures. And they're all there for a reason, because a plant doesn't eat dirt. A plant doesn't put its roots into the soil and take up things like we heard about a micronutrient recently from Lee just a minute ago, iron, right? A plant doesn't put its roots into the ground and suck up bits of iron from rock. Because what's soil? What is soil? When you think of soil, I guess most of us think of it as dirt, but it's not. Essentially, soil is crushed up rock. It's a mixture of sand, silt, and clay. They're just different grades, different sizes of crushed up rock. And they have all the things that, the minerals in that we might think of: calcium and phosphorus and magnesium and boron and iron, whatever. All those things that are in that bit. But that's not soil. Soil is only soil when it has that life. Because a plant doesn't eat dirt, right? A plant needs some things that are in dirt, but it doesn't eat them. Just to frame this, I didn't understand photosynthesis, and photosynthesis is quite important as a concept when you're growing food, apparently, I learned. So photosynthesis, when I was young, when I went to school, I was taught that a green plant uses the sun's energy, and what it does is it uses the sun's energy to breathe in carbon dioxide and breathe out oxygen, right? And this is beautiful because we breathe in oxygen and we breathe out carbon dioxide. So a plant photosynthesizes, and it essentially takes carbon out of the atmosphere and it gives us back oxygen. What a beautiful thing. Like, it's kind of magic, isn't it? It's kind of great. But that's not actually the magic of photosynthesis. The magic of photosynthesis is that, yes, a green living plant, every single green chloroplast is the original solar panel. They do take in the sun's energy, and they do take in carbon dioxide. But the magic of photosynthesis is not that. The magic is that when the plant takes in the carbon dioxide, it also takes up a bit of water, usually from its roots. It uses the sun's energy to split carbon dioxide and water, split them apart, and recombine them as carbohydrate. A plant makes carbohydrate, sugar, which is energy, out of thin air. That's photosynthesis. It's utterly amazing. So when you eat a carrot, 99.9% of that carrot came from here. Gases in the air, carbon, hydrogen, nitrogen, oxygen, right? But there's some other tiny, tiny, tiny fractions of stuff in a carrot that are really important. And those things come from soil. They are the minerals. So what a plant does, when it's gathering all this energy from the sun, and it's creating sugar out of thin air. So sugar, energy in digestible form. Every other life form on Earth relies on a plant or in the ocean on an algae to produce sugars out of thin air. Like, I'm of English and Welsh and Scottish extraction, right? I lie in the sun for any length of time. Right? I don't create my own food. I get a melanoma, right? And I'm still hungry, right? A plant makes its own food out of thin air. But the interesting thing is, only about 60% of the energy that the plant creates out of photosynthesizing does it use. It uses that to build its structure. It uses it to fight disease, to deal with stress. But about 40%, on average, every plant varies, 40% of the energy that the plant is creating out of thin air, it's putting into the soil. It's dribbling carbon molecules, mostly sugars, but sometimes amino acids, the building blocks of protein. Sometimes it's putting fats, up to 100,000 different chemicals a plant can be dribbling out through the ends of its roots. And it's essentially feeding the underground ecosystem. And so why does that matter? That matters because those things living in soil, they're like you and me. They don't make their own food. So the things living around the roots of the plant are reliant on the plant to take sunlight and turn it into energy in digestible form, carbohydrate, and put it and feed all the things that live in soil. So the plants do this beautiful thing for soil life. But it's not a one-way street, because the plant's not doing that for nothing. What the plant does, it actually has a relationship with living things in the soil, fungi, bacteria, all sorts of things, even viruses. The plant can actually, and this is going to sound mad, but the plant can actually communicate. Plants can talk, right? Essentially, they talk to the underground ecosystem, and a plant might say, I need nitrogen. And say the plant has around its roots some fungi, it can say to the fungi, I need nitrogen. And the fungi goes, I haven't got any nitrogen, but I've got a mate over here who's got some nitrogen, because fungi are long threads that stretch through the earth. The fungi can find the nitrogen for the plant. And the plant, and the fungi goes, great, I've got the nitrogen, or I've got along my stem, I've got some bacteria that dissolve phosphorus. You want some phosphorus? And the plant's like, oh, bloody hell, yeah, I need phosphorus to grow well. That'll be handy. And the fungi goes, yeah, great, well, I've got that, but guess what? You need to pay me, and you pay me in carbon. So this underground economy going on all the time, this beautiful ecosystem under our feet. So the only reason we have life on Earth is because, there's a cliche from the 30s, I think it is, it probably came from America, The only reason we have life on Earth, the only reason humanity exists is because we have 6 inches of topsoil and the fact it occasionally rains. There is no life on planet Earth without topsoil, right? And I can tell you, living in Australia, 6 inches of topsoil, dreaming, right? We don't have that much. Most of Australia's got like 2 centimetres or a centimetre worth of topsoil. But still, that dark bit, topsoil's the dark bit when you dig into it, that's the bit that allows us to grow food and fibre. Something like 98%, 99% of all the calories that humans consume on Earth come from topsoil, the fact that we have topsoil. And the stuff that comes from the ocean is only probably there because there's runoff from our land, nutrients that run off from our land that runs into the ocean that feeds, because most of our seafood comes from around the coastline where we get runoff. And the problem we've got is that topsoil is imperiled. We have lost so much topsoil. We're losing topsoil at crazy rates through the way we farm, through the way we build our cities, through climate change, through natural events. But topsoil can be made. It can be made at the rate of, so in Europe, maybe after 1,000 years, you make an inch of topsoil. In Australia, after 1,000 years, you might get a centimetre of topsoil. And that's made by plants, growing and shedding their leaves and their roots dying and building this ecosystem, and gradually build up more and more living stuff and organic matter in the soil, in the top bit. And that makes it more fertile. But we're losing topsoil through the way we farm, the way we grow food. To put it in context, there's a lot of different numbers out there, but one that sort of comes up a fair bit is we lose, on average, for every breakfast, for every lunch, for every dinner, for every human on Earth, we lose about 9 kilograms of topsoil that's washed or blown away. So that's like a bucket. Imagine next time you have a meal, a bucket of topsoil has been lost for you to eat. And farming is the big culprit here. Farming is the main reason that we lose topsoil. And yes, topsoil is being rebuilt, but it's not being rebuilt at anything like the rate where you're losing it. We lose, on average, a soccer pitch worth of usable land due to the damage that's happening to topsoil and desertification. We lose, on average, a soccer pitch worth of land every 5 seconds. So what's that? It took me about 20 seconds to say that, didn't it? We lost 4 soccer pitches worth of usable land. And I just want to do a quick demo of how much land we've got. I can't see my timekeeper, but I'm sure I've got plenty. 5 till questions? Great. I just want to give a demo. So it seems like there's soil everywhere. Maybe not in Singapore, but even here, it's so wonderful. There's so many open spaces and so much greenery. It's lovely. But it seems like when you travel the world, there's topsoil everywhere. So I was like, I'm a farmer, I grow stuff. How much topsoil is there? So imagine this is the planet. Imagine that's planet Earth, right? Topsoil all over it. Well, no, not quite, because we have to lose half, because that's ocean. Oh, actually, sorry, that's ocean too. So really, that's how much land there is. But we've also got areas that are too rocky, too high, too swampy, too dry. You can't grow stuff on the polar ice caps. So we lose another half. So we're down to about this much of the world is potentially good for growing food. But we've also got areas that we're not going to cut down. We've got cities. If you add up all of the urban areas on the planet and put them together, it would be about the size of Western Europe. That's land that's very hard to grow food on. We can grow a little bit, but not huge amounts. We've got areas that we're going to preserve that we're not going to grow food on. We've got other areas, grasslands, where you can only graze animals. There's a difference between arable and non-arable. So arable land is where you can grow a crop. So vegetables, grains, fruit, things like that. Most of Australia, 92% of Australia is not arable. You can't grow a crop there, okay? So we have to get rid of some of this. In fact, 3/4 of that. So then we're down to that bit. This is the bit of earth that is left for us to grow crops on. To grow the fruit, the vegetables, the grains, the pulses, the legumes. And we're losing this at crazy rates. So when I talk about topsoil, I think of it as I think of the nutrient density we're losing in our crops. I think of how we're losing topsoil more broadly. We know there's things that live in soil, Like when you eat an organic spinach leaf, there are potentially 600 different microbes on there. And we know that those microbes inoculate the human immune system. We know that people who are separated from soil are more likely to have gut and brain issues to do with, and autoimmune issues to do with lack of access to soil. We are evolved to be around living soil. Not just around soil, but around living soil, the good things that live in soil. But we're losing it at stupendously high rates. The good news is there's people been growing food for thousands of years and not buggering up topsoil. Typically what's happened, humanity, the biblical regions, the breadbasket of biblical times is now a desert. That's a really good example of what's happened over time. We grow food. Farmers have humanity has worked out how to grow food in a Western agricultural sense, set up a farm, and when that land is buggered, when they've ruined the topsoil, they move on. Right? We've done that over and over and over and over again. I've done that. I bought a farm, overgrazed it. Phew, not my problem anymore, sold it, right? But we can't do that. We're running out of spaces. There's no soil on Mars. There's regolith, dirt, there's crushed up rock, but the things that live in and on soil that make soil what it is, that make us what we are because it inoculates us and our immune system, doesn't exist on Mars. So we have to work out how to grow food here better. And the good news is we can. There are farmers all over the world who have come up with ways. Sometimes it's ancient wisdom where they've been growing things on terraced fields for 2,000 years without losing soil fertility. There are modern farmers who are working out how to grow food and build topsoil at the same time. And just before we go to questions, to give you an example, and I'm not a very good example, I only learned how to started farming 18 years ago, but we have 70 acres. On 70 acres, we reserve 40%, 39% for wildlife. We grow 10,000 meals a year on that property. And I'm not talking like 10,000 loaves of bread. I'm talking high quality protein. I'm talking leafy greens. I'm talking root vegetables. I'm talking fruit, nuts, dairy. We store more than we emit carbon dioxide. We store 150 tonnes more carbon dioxide each year than we emit, including this ridiculous flight to Singapore, right? We grow food. For every kilogram of pork I produce, I store 77 kilograms of carbon dioxide out of the atmosphere. How do we do that? Because we see soil as the most important thing. Not the pigs that walk over the top of it, not the cows that graze on it, not the vegetables. We have a market garden. We grow all sorts of vegetables. That's the hardest place actually to store carbon is the market garden. But what we do is we say the only reason we can eat is because we have healthy soil. The only way we can grow more is to make the soil more healthy. And how can we improve the ecosystem in which we farm while growing nutrient-dense food in the process? So that's what we do. And we're a living, breathing example of that. So, how do I go for time? Great, cool. Time for questions? Cool.
Thank you, Matthew. So we have a couple of questions there. Maybe you want to tackle some of them. I guess one of the simple ways that we could increase soil nutrition would be, and I think if you've been in Singapore, I mean, if you've run around, you see a lot of greenery, but is there nutrition in that soil, and how would we be able to increase that?
Yeah, so soil nutrition. So soil, the big thing for soil is soil can heal itself. So soil hates to be bare, so having green living plants the whole time. It hates to be turned over, so ploughed or dug over. That's really bad for soil. About a quarter of the carbon dioxide increase in the world today comes from the fact that we have ploughed land and released carbon that was in soil and released it into the atmosphere. There may be localized depletion. So you might live in an area that is low in iron, or there's low in boron, or low in calcium or something. So you can get tests for that. But most of the things that exist in soil exist in this sort of crushed up rock. And it's just that having the biology to extract it. So soil wants diversity of plants. It wants green living plants. It wants to be covered the whole time, and it doesn't want to be disturbed. They're the big ones.
So if I'm hearing you right, to keep soil healthy, we should at least give it space and time to be by itself for a while.
Yeah, well, yeah. So typically when you grow food, Well, most people want to eat annual vegetables. So annual vegetables, an annual crop versus perennial. An annual crop is, say, a carrot's a good example. You take a carrot seed, you plant the carrot seed, everything else wants to grow. It dies if you don't water it. You've got to weed the area. And then when you go to eat the carrot, you eat the carrot and you kill the bloody carrot. Next year, you've got to grow another one, right? Humanity, when they got into annual vegetables, dumbest idea ever. Perennial is like an apple tree. You've got a tree, you go and take an apple, and you eat it, you don't kill the tree. Next year, oh, I can eat another apple. I don't have to weed it, I don't have to water it, I don't have to do anything. So what we've done is created a system where we have to keep growing stuff that wants to die, and conventional farming tries to kill the stuff that's trying to live, so all the weeds that will grow in between all of the crops. But what soil needs is diversity, so you can do that over time, so you don't have to have 16 different crops growing at one time, but you can rotate crops, and you can, there are ways now to grow things with less digging of the earth, which is really good for soil health. There's all sorts of techniques, ancient and modern, to look after that.
Okay, that's interesting. There's a really interesting question here. How do you suggest countries like Malaysia retain topsoil? I mean, it's a country that's big on commercial cash crops like palm, durian, and how do you balance that sort of commercial viability and sustainability? And I mean, it's just not Malaysia, right? Like you have cacao, you have coffee around the world, and these are large commercial crops. And how do you suppose that could be fixed?
Yeah, so most things, and I'm no expert on sort of tropical climes, but most things like to be rotated. So if you're going to grow, or certainly things like coffee live on for a long time. So if you've got a coffee plantation, but they're usually an understory. Traditionally, they're an understory. They've been grown just as a monoculture. But you can grow. I've been to places like East Timor where they're growing them as like it would originally, an understory tree. So maybe, I don't know if they would grow under jackfruit. You can harvest the jackfruit and then you can harvest the coffee. You end up with a more resilient system. So there are ways to build resilient systems to try and reduce soil loss. So either rotating the crops around, not growing the one crop year after year after year, or if they're perennial, then how do you have a nice system that looks after the long-term health of the soil while harvesting year after year.
So that's interesting also. I mean, it's not on the list, but I'm quite curious to know also then, these commercial crops tend to also use a lot of chemicals that help control pests or herbicides and the like, right? And that is super detrimental to the soil. I've seen them when you go into palm oil estates and you see that it's not soil, it's clay, right? And it's dead ground. Is there an alternative to that?
There was always alternatives, and it's a balance between soil health and... So soil has a really long time frame. So soil sort of works in geological time, which is, human time frames are not anything like that. So what we tend to do is we tend to go, I need the harvest today, or I need it next year and I want to make money. So there's this tension between what soil needs and what humans need. But there are clever people all around the world working out ways to reduce chemical inputs, because you're right, pretty much all of the pesticides, herbicides that we use are detrimental to either the soil health or the ecosystem that might support soil health in the long term. And you might not see it in the short term, but they're generally bad in the long term. But there are people who are coming up with ways to do that kind of thing. So for example, where we live, we've got a problem with aphids eating a lot of our crops. So what we do is we grow a lot of flowers. That doesn't seem like a sensible thing to do, but we have these hoverflies, these tiny little flies. They lay their larvae into aphids, and so the more flowers we have, the more they hang around the garden, so the more their babies eat the aphids. So there are biological methods, but it doesn't mean there's no aphids, it just means there's a lot less.
A lot less and controlled.
Yeah, it's about controlling it, and it's trying to work with nature. And so soil is an ecosystem, as above ground has an ecosystem, and we try to work well. And the best farmers, I think, work saying that's an ecosystem, what does it need, how do I give it what it needs while getting what we need? And what we need is to feed ourselves and to clothe ourselves, and sometimes we have to, we might say it's more important to do certain thing which is better for us, but in the long term we have to favour soil or we're doomed.
Yeah, interesting. I think we've got probably one more last question. You used to be a chef, or you still are a chef. How do we help chefs understand more about the importance of soil, and how do we get them to care?
How do you get anyone to care about soil? When I first suggested a book, I went to my publisher and I said, I've written a book on soil, and she'd done 13 books with me before, and she went like this. And I'm thinking, she's going, oh my God, there's all this living stuff. Oh, ecosystem. There's wonderful soil superorganism underneath our feet. No, she was avoiding my eye because she's like, oh yeah, he's gone loopy, he's into soil, right? How do you get them to care? I think from my point of view, the really easy one is nutrient density. So, okay, soil health, the more living things you have in soil, the more access the plant has to all those cool things that it wants from soil, the better tasting the plant, and the better tasting the plant equals nutrient density. So those things are intimately connected. So the more I look after soil as a farmer, the better my food tastes on the plate. And chefs are intimately connected to their palate. And if we're all given one gift to be able to tell the nutrient density and the complexity of what's being grown, it's this thing on the front of our face, the ability to be able to smell and detect complexity and deliciousness. And that's where what a chef does and what a farmer does, they come together. I mean, like that intuitive knowledge, that deliciousness doesn't work with donuts, right? But it works with a carrot. If one carrot is inherently more delicious and more complex tasting, it's probably grown in more healthy soil and is more nutrient dense.
So I'll just take that question just one step further. When we talk about deliciousness, for example, often it's usually connected to a sort of like a higher calling of food, for example. But we also have the responsibility to be feeding a lot more on the masses, right? And how would we be able to speak this truth to chefs who are dealing with like a larger amount of people that they're feeding?
What's sort of amazing is there are people working out ways to look after soil health, not like me at home with my little garden, my tiny little veggie patch that I feed the family, ways to scale it up. And there are people actually working out how to scale it up. So these are people who sell into supermarkets currently who are saying, you know what, I've worked out a system where I can, if I do, I grow different crops in between, then I have less passes with my tractor, less chemical use, and my produce is tasting much better. So it's sort of happening, but it just needs to happen much faster and much more broadly.
More broadly and more globally, I suppose.
And definitely globally, And a lot of the numbers you might hear about food have to do with the global sense, and Lee pointed out sub-Saharan Africa. Like, whenever you look at carbon emissions from livestock, a lot of the numbers come from, places that aren't, that have a lot of food insecurity. So what they're trying to do is really, they're just trying to feed themselves. And they're not really thinking about 10 years down the track, because they're just thinking about 10 days down the track, and are they going to get through? And so how do we get rid of that inequality and allow them to be able to have the luxury of going, well, I know I'll be able to eat today, and if I can eat today, then I can look after the soil health for tomorrow. And I can't fix that one.
Yeah, fascinating. Thank you very much, Matthew. Let's round of applause.
Thank you.
Thanks, man. Sorry about that.
Yeah.